Hi guys, today's lesson is on translations and dilations, Unit 7, Day 1. The objective is I will be able to describe the translation and dilation of a geometric figure on a coordinate plane. So, Unit 7 is all about transformations. And a transformation is an operation that changes a geometric figure. There are 4 kinds of transformations. First one is translation, second, dilations, third is a reflection, and the fourth is a rotation. The ones we're talking about in this lesson are the first 2. Translation, which is a change in location, and a dilation, which is a change in size. If you guys take a look at the 4 images over here, 1, 2, 3, 4, each one of those images is represented by a translation, dilation, reflection, or rotation. Take a second and see if you can figure out which one goes with which of these transformations. Now there's some specific notation that goes with transformations. It's always that the old or original figure is called the pre-image, and then the new figure is called the image. Transformations also use this prime notation. And when we say prime, in math, most of the time that means apostrophe. So if we look here, the way that I would read this notation is triangle ABC becomes triangle A prime, B prime, and C prime. We know that ABC is our pre-image. If I could spell that correctly, that would be great. And then triangle A prime, B prime, and C prime is our new image. And it goes through some kind of transformation. Our first transformation that we're talking about is a translation. Translations is when we have a change in location, right? That means our triangle, A, B, and C, moves so that it's in a new location, okay? Each point of the figure moves the same distance and the same direction. So if I were to take any of these coordinate points here, and let's take a look at B. It goes this much over. It's going to be that same amount, and then it goes this much up, right? When we go from A to A prime, it's going to go over and up the exact same distance, right? So it's going to go over 1, 2, 3, 4, 5, 6, 7, 8 units, and it's going to go up 4, 1, 2, 3, 4. And that's true for any point along your triangle, okay? Translation is usually associated with 2 directions, the horizontal, left or right, or X direction, and the vertical, up or down, or our Y direction. Now, translations are congruent transformations. Congruent here, we know means same. So even though we're changing the location, the size and the shape of our pre-image stays the same in our image, right? If we look at the area of our triangle here and the area of our triangle here, they stay the same. It takes up the same amount of space, it is the same shape, it is the same size. In order to determine the new image, we can use this rule. Any coordinate point, x, y, going through transformation A, B, goes to x plus A and y plus B. What that means is our A represents the number of units shifted in the x direction, while B represents the number of units shifted in the y direction. So if we go back to our image over here, let's take the point B which is 1, 1. And we're going to translate that 8 and 4, which means we're going to go from point B, and then we're going to go 8 to the right, 1, 2, 3, 4, 5, 6, 7, 8, and then we're going to go up 4, 1, 2, 3, 4. We get this new coordinate point, B prime, which is at 9, 5. And we got that by doing 8 plus 1, 1 plus 4. All right, so that's how we can use our transformation rule to figure out all of our coordinate points. That means if we had C, point C here is at -2, 3, and we're trying to figure out what C prime is, well, it's going to go the same amount left, right, and up. So we can do -2 plus 8 which gets us to -6, and then 3 plus 4, which gets us to 7. And that would be your coordinate point for C prime, and so on and so forth. Let's go through this teacher example right here. The given triangle EFG is the pre-image. It is translated so that point E is now at -1, -2. That means at -1, -2, here, this is E prime. The first thing that we should do here is always label what is our coordinate points for E, F, and G. This is for our pre-image. So E is at -4, 3. F is at -4, 5. And G is at 1, 1. Now what it's asking for is to use our A-B notation to describe the translation, is the first thing, and then to determine the coordinate points for point F prime and G prime. This is a new image, okay? So we know here, our image for E becomes -1, -2. So one way we can do this is actually just to count. We're going to go over 1, 2, 3 units in the positive direction, and then we're going to go down 1, 2, 3, 4, 5, which means our rule is going to be 3, a positive 3, and then a -5, right? You're going to go 3 right and 5 down. So that's our rule. Describe the translation using A-B notation. It's right here. Now what we can do is apply that rule to our coordinate points for the pre-image F and G. So here, if we use 3, -5, we're going to do -4 plus 3, 5 plus a -5, which means our F prime is going to be -1, 0. Which means that puts us right here. I'll use a different color. Here's F prime. And then doing the same thing here for G, we would do 1 plus 3, 1 plus a -5. And then our G prime becomes 4, -4. And then again, that becomes 4 and -4, which is right here. And then we can actually draw our pre-image, just like that. So here are the coordinate points for our image, F prime and G prime. Work through these independent practice problems on your own a little bit. And then when you get to number 4, I do want to do this one together because it's a little bit tricky the way that it's worded, but it's really important. So the image of point 4, negative 6 under translation P is 12, negative 9. What is the image of point negative 2, 7 under the same translation P? Determine what the A and B translation is for this transformation. What's really confusing is it actually gives us the image and the pre-image, but the way that it's worded, that's really hard to understand. So I'm gonna draw it like this. Here's our pre-image, 4, negative 6. It goes through translation P. This is our, but we don't know what that rule is yet. It's some rule. And then we get our image, which is 12, negative 9. So in order to go from 4 to 12, we know that it's going to go to the right 8 units. So this first number we know is going to be an 8, because if you do 4 plus 8, we get 12. We also know that if we have negative 6, we're going to need to go down 3 units to get to negative 9. So we get negative 3, right? So that's the rule for this translation. That's what translation P is telling us to do. So it's asking if it goes through that same translation, that same rule, then what is the image if our pre-image is negative 2, 7? Well, then it's going to go through that same rule, 8, negative 3. And then we're going to get negative 2 plus 8, and then 7 plus a negative 3. We end up with 6 and 4. So the answer to this, the image of point negative 2, 7 under the same translation P, is 6, 4. All right, the second kind of transformation that we'll be discussing is a dilation. And a dilation is a change in size. They form two similar figures, and that means angles are congruent and sides are proportional. And we can use the term scale factor to describe how much of the size has changed. And we do the scale factor by doing the new divided by the old. And scale factor is oftentimes denoted with a K, and sometimes it'll be this fancy cursive K. All right. The way that we can use a rule is if you have a coordinate point x, y, and you know what the scale factor is, then you can multiply the x and the y by the scale factor and you get your new coordinate point. So again, here, this is our transformation. Right? It's going to tell us how much bigger or smaller is our new figure. And then this is our pre-image. And this is our image. Okay. If you have a scale factor that is greater than 1, it is an enlargement. It is larger than 1. If your scale factor is between 0 and 1, then your dilation is a reduction. It means it's going to get smaller. Okay. So let's take a look at this picture right here for a second. We know that this red triangle is our pre-image. And the reason why we know that is because if you look very carefully, this is an A, this is our A prime. A prime always indicates the image. So just by looking at this, we know that it's going to be an enlargement. We know the scale factor K is going to be greater than 1. So what we can do here is this point A is at 4, 5. Right? 4, 5. And then our image over here, if we do this very carefully, is at 12, 15. In order to find the scale factor, we're doing new over old. So 12 over 15 is our image, and 4, 5 is our pre-image. So what number, 4 times what gives us 12? 5 times what gives us 15? Well, we get 3. That means our scale factor is 3. So it's going to grow by a factor of 3 between our pre-image and our image. That means, let's say we didn't know what C prime and B prime, what those points were. Well, we can look at point B over here, and we know that it is 3, 2, where K is equal to 3. Then we can do 3 times 3, which gives us 9, and 2 times 3, which is 6. And then if you look over, here is 9, 6, and we find there's your B prime. Here's a teacher example. Rectangle ABCD is shown below. If point A is dilated through the origin, and all of the problems that we're doing in geometry will be dilated through the origin. So that point A prime is at 9, 3. Determine the following. What is the scale factor? Is it an enlargement or reduction? And list the vertices for B prime, C prime, and D prime. So let's take a second here to find where is our new A point going to be. A prime is at 9, 3. So here's 9, 1, 2, 3. It's gonna be right here. So this is our A prime. And here is our point A. So again, the first thing that I'm gonna do is actually just write out the coordinate points. A, B, C, D for our pre-image. So A is at 3, 1. B is at 1, 1. C is at 1, 2. And D is at 3, 2. Okay, now for our image, A prime is at 9, 3. And then we're looking for B prime, C prime, and D prime eventually. Now in order to find the scale factor, we need to do new over old. So K is going to be new over old. Our new image is 9, 3. Our old image is 3, 1. So this is A prime and A, which means our K is a factor of 3, right? So that is our first question. What is the scale factor? Our scale factor is 3. Now, since 3 is a number that is greater than 1, it is going to be an enlargement. That means our rectangle is going to get bigger. And from there, we need to list the vertices for B prime, C prime, and D prime. And all we need to do is multiply all of these numbers by 3. So B is going to go 1 times 3 is 3. 1 times 3 is 3. C is going to be 3, 6. And it's going to be 9, 6. All right, and then if we just plot those points real quick, 3, 3 is going to be right here. 3, 1, 2, 6. And right here will be 9, 6. So this is B prime, C prime, D prime. We get our transformed rectangle over here that looks just like this. And we can tell that it is quite a bit larger than our initial rectangle. Take some time and try these independent practice problems on your own. All right, that's all for this lesson. Thanks, you guys.